A railgun is a device that uses electromagnetic force to launch projectiles by means of accelerating them along a pair of conductive rails. A conducting projectile is placed on the rails, and as current runs through the created circuit, a magnetic field is induced, which propels the projectile forward. This video shows how a real-life railgun used by the US military performs in testing, but sadly, our railgun is not of this caliber.
Boom! 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 Pow! Boom!
The alligator clips are attached to the positive and negative terminals of the battery and to the aluminum foil, creating an incomplete circuit. The addition of an aluminum rod completes the circuit and allows current to flow from the positive terminal of the battery to the negative terminal of the battery. On its own, the aluminum rod will induce a magnetic field due to the current flowing through it, which can be determined to be inside of the page, inside the circuit, using the right-hand rule. But an external magnetic field is required to provide enough force for the rod to move along the aluminum foil. The external magnetic field is provided by the addition of magnets within the circuit, whose magnetic field direction, in this case out of the page, overcomes the magnetic field induced by the rod by a tremendous amount. Using the right-hand rule, you can see that the force on the aluminum rod will be towards the battery, therefore rolling the aluminum rod in the direction of the battery.
We used cardboard as our base, many circular magnets to provide a magnetic field, and aluminum foil to act as our current. One of our challenges was that we had to put on our cardboard multiple times because the aluminum plate on top had to be really smooth because it had to overcome the static friction of the surface.
I'm excited. Go. Something right now. It's like if you don't shampoo for like.
In conclusion, using tracker analysis, the movement of the rod was continuously measured in order to create a graph of its displacement. The line of best fit for the graph was determined and was used to be its derivative. The derivative of a displacement curve is the velocity of the object, and a derivative of the velocity curve of an object is the object's acceleration curve. In this case, the velocity curve is linear, and therefore its derivative is constant. Thus, we can see that the acceleration of the projectile on this railgun is 0.21 meters per second squared.